Hey everyone, and welcome to our video on quadratic function applications, where we will be finding a maximum or a minimum. So let's read this problem. It says, Lily finds that the cost in dollars of producing X widgets is given by C of X equals 7X plus 200, and that the revenue from selling X widgets is given by R of X equals 40X minus X squared. Okay, so just looking at these functions, we can kind of make a note right now. This is a linear function, so notice it has the form y equals mx plus b. So that is a line. If we wanted to graph it by hand, we can know it's going to be the shape of a line. This, because it's got a square on the x there, it is a quadratic. Okay, so that way we know it's going to be a parabola. Now, I'm going to do this one using our Desmos graphing calculator. Okay, so I just went to Desmos. I just typed it in the top there, and then let's use the graphing calculator. And that way we can do number one, graph both functions. Okay, so let's just type it in exactly as we see it. So 7x plus 200, and then 40x minus x squared. Okay, so notice it's not giving us much to actually look at because the window's too small. So this is what's nice. You can zoom out with this pretty quick. But notice it's kind of not very accurate. So that's where you can use this wrench, the graph settings. First, let's make it a little bolder so we can see it better. And then let's change our axis. Okay, so what's probably important to us for an application is for everything to be positive. So I'm just going to go ahead and do 0 here for the smallest x value. And then looking at our graph, it doesn't go very far to the right. Based on this current grid, it looks like that would be 100. So this is 50. Okay, so now it's all stretched out. And that actually might be good. Okay, so the y-axis you can mess with if you want to. But I think this is good, and that because I'm just going to scroll over a little bit to see what I really need to see. Okay, so there's everything. And with this, so the blue graph, it shows our vertex. So the vertex is 20 and 400, and then it has the y-intercept and the x-intercepts. Okay, so there's our key information. It also shows where the graphs cross. Okay, so let's go ahead and make this sketch. So I'm just going to kind of copy this first quadrant down here, and I'll be labeling my points. So I have the parabola, something like that. This was 0, 0. And then this is 40, 0. And the vertex, let's label V for vertex, was 20, and I forgot, let me scroll, and 400. Okay, so there's those 3 points there, so 20 and 400. Okay, so we're going to bold that. So this is the quadratic function, and let me use a different color. My cost function, or my C of x, which is linear, was that line that went something like this through it. Okay, so there's the line. So this was our C of x, just to mark it, and in the black was the R of x. Okay, and in the C of x, though, let's get those points plotted. So on our graph again, so I have to kind of go back and forth. The y-intercept was 0 and 200. And then let's get those 2 points also labeled on the picture. Okay, so we have 0 and 200. And then this one was, actually, let me do a different color. Let me do it in blue. 8 and 256. And then this one was 25 and 375. Okay, so this is going to help us with the rest of this problem. All right, so in step 2, it says find the minimum break-even points. Well, or break-even quantity. The break-even, when talking about cost and revenue, is where they equal each other. Well, they equal each other where the graphs intersect. And we're solving for x values when we're doing this. Solve for x. So if I were to substitute these actually in, we could solve it using our methods to solve these types of equations without a calculator. However, the calculator we already had used, and we can see those intersection points. It's the x equals 8 and x equals 25 is where that would be, is where they are both equal to each other. So x equals 8 and 25. Well, in this problem, they asked for the minimum. break-even quantity. So that means 8. Okay, so x equals 8. And it would be widgets, whatever the unit is, and it's widgets in this problem. So when x equals 8 widgets, we have broken even. Okay, so moving on to number 3. Find the maximum revenue. Okay, so this is only about revenue. Find the maximum revenue. So that means, remember that, so, or if you're going in order, if you're not, we'll break it down here. Maximum revenue is a quadratic function. The max or mins occur at the y-coordinate of the vertex. So that means all I have to do is look at my graph and say, well, it's 400. So the 400, or let's write the max is, so it's a maximum because that's the biggest y-coordinate that I have in this graph. So that's why it's a max instead of a minimum. So the max is 400, and it doesn't say what it, oh, it is. It's in dollars. Okay, so is 400, let's just do our symbol, $400. Okay, so the max is $400 when x equals 20 widgets are sold. Okay, so that's it. So you just have to look at the vertex. Whenever you have a quadratic, that's all we have to do. Okay, and then number 4 in this problem is saying find the profit function. So profit function is the revenue minus the cost. And this is where we would use a substitution. When you sub them in, make sure to use those parentheses. Okay, so I'm just going to go ahead and get those spaced out. So I have my profit function is the revenue, which is the 40x minus x squared, minus the cost, which is 7x plus 200. Okay, so I put those parentheses there. So they're needed, but it also helps with the colors, I think. This minus will distribute. So we have to make sure the signs are correct. Okay, so we've got 40x minus x squared minus 7x minus 200. And then what I'm going to do is rearrange it so it's in descending order. So I'm going to write it as negative x squared. The 40x minus 7x would combine. That would be plus 33x. And then we have minus 200. Okay, so that is the profit function. So that's what they wanted in the first part for this number 4. And then what they want is the maximum profit. Okay, so maximum profit now. Well, notice our profit function is a quadratic. So that means how about we graph it and then look at the y-coordinate of the vertex. Okay, so let's go ahead. So I think I'm done with these. And let me type in this new equation. So the negative x squared and then plus 33x and then minus 200. Okay. So there's our parabola. And then now I got to look at the vertex. Well, the graphing calculator gives me the vertex. It's right here. Okay, so we've got 16 and a half is the x value. 72.25 is the y value. Okay, so it looks like the maximum profit. Okay, so let me write that vertex real quick. Okay, so the vertex was, and I'm just moving it over so I can see it. The vertex was 16.5 and 72.25. Okay, so using this vertex alone, we could say the max profit is 72.25 when x equals 16.5 widgets. Okay, so that's if they don't care about rounding. So that's that. However, if they do, because you probably can't have a half of a widget, we would want to round up. Okay, so I can go to my table. So that's here. And we could type in, okay, so 16, 16.5, and then 17. Okay, so notice, so I just wanted to show the whole numbers between 16 and 17 and 16 and a half. It looks like it's rounding up to x equals 17 would give us $72. So just in case they say you can't have a half a widget, then we would round up. So the max profit is $72. I'm just going to write at x equals 17 since I'm running low on room. Okay, so that's if it is a decimal answer for the x coordinate. We might need to round. All right, but either way, it's there. You're just looking for your vertex, and from there, you kind of have it. Okay, so that's the first one. Let's write it as r of